Welcome back to our 9th grade Introduction to Technology Education series as we start on our next unit where we talk about engineering. And our first little presentation today is going to talk about engineering structures and elements of design. This is a really interesting comic here where it says, if you look, the bridges are not connected. When did you say they'd have our resumes printed? Things that can happen when engineering goes wrong. The essential question for this unit is basically, what design considerations need to be addressed when engineering solutions? You go through this process all the time, even in science. When you go through the scientific problem-solving process, it's very similar to that. So you think about these processes, but you don't really assign them a name or think of it as a sequence of steps. So let's look at what's going on here. Technology design process. It's kind of a continuous loop. Ask, imagine, plan, create, improve, all circling around your goal. If we do not continue to loop and to improve as we design something, we'd still be driving cars back from Henry Ford's Model T Ford. So it's always a constant improvement and a constant process. It never changes. So let's look at the steps of this sequence. Under the ask category, you got to ask a couple of questions. What is the problem? Sometimes that's not really easy to define. Sometimes something isn't working and you have to try to figure out what that problem is. In technology and computers, that can be a whole task in itself. You want to ask yourself, what have others done? Why reinvent the wheel? See what's out there. You have all this information at your fingertips. We are in the information age, so look to see what's out there rather than try to start from scratch. See what other people have done. What are your constraints? What are your limitations? What do you have to work with? Maybe you have a material or a cost limitation. So think about those goals first. Imagine. What are some possible solutions? Brainstorm out ideas. Brainstorming can sometimes throw out some really ridiculous ideas, but those ideas can lead to some really good ones. So think about what's going on. What are your options? What are you trying to come up with? Brainstorm ideas. Choose your best one. Plan. Plan this out. Make a diagram. Make a list of materials that you may need. Many people fail to plan. They just go in and they think they're just going to pound something together, and without a good plan, you're probably going to be destined to fail. So develop a plan. Make a diagram. Make a list of what you need to do, and maybe even a list of steps. Create. Follow your plan and create it. Test it out. Create your solution to your problem. After you test out your solution, you want to look at improving it. Talk about what worked, what didn't work, what could be working better. Modify your design to make it better and test it out again. And continue to circle in that loop. So, one of the best ways for us to talk about problem solving and basic structures is to look at something called the Truss Structure and how it's applied and how other structures are used in, say, building bridges. Because a lot of these design ideas that we use in bridges can also be used in other structures. Here you'll see a whole list of some different structures, and in class we will actually examine some photographs of real bridges and try to see where they fit into these different categories. Let's talk about the truss structure, because you're going to see it everywhere. Truss structures are used in just about everything these days. We can't make stuff out of solid material because, for one, all of that material becomes expensive, it becomes heavy, and also in a video that I'm going to have you watch later on, you'll see that a solid structure can actually cause some very drastic problems in terms of wind and dynamics. But here's just some pictures of where you can see trusses in place. You can see them in towers, in bridges, in roof structures. The roof of the school, even though it's a flat roof, it's going to look a lot like that picture in the lower right hand corner. And even an airplane is going to use truss structures. You want it to be light. A truss is going to make it light but also make it very rigid. So how does a truss structure work? Basically, what you're doing with a truss is made up of triangle shapes to create a rigid structure. And by using a bunch of smaller triangle shapes fastened together with other triangle shapes, you can span a long distance. So a truss. Triangle is a rigid object. It can't be distorted without the material failing and breaking. Squares, on the other hand, can flex. So a square can bend. Now, if you put a diagonal through that square, you just turned it into two triangles, so in essence, you've just turned that into a truss structure. So the structure is now rigid and cannot easily flex. Benefits of a truss structure. Well, you don't need to use as much material as a solid structure would use. They can be lighter structures, meaning they do not need to be as massive to be able to even support its own weight. They're able to span longer distances in solid material of equal size. And for towers, less wind effect on the structure, because the wind can go through the structure rather than slamming into the side of it. Now, for this short lesson that we did, there is a video that I'd like you to watch that I have available on the class canvas and also in my YouTube channel. It will not play well through this PowerPoint, but it's a bridge called nicknamed was called Galloping Gertie. It's the Tacoma Narrows Bridge, but it's a suspension bridge where our technology, our engineering understanding of materials far exceeded our understanding of aerodynamics. The bridge surface became so light that a heavy wind caused it to resonate and bend and flex. So take a look at the bridge about the Tacoma Narrows Bridge collapse, also called Galloping Gertie, and enjoy.